Hey everybody, this is the Toolkit for Unit 5, Lesson 2, Investigation 2, solving equations of the form mx plus k equals ax squared plus bx plus c. So basically we're looking at linear equations and quadratic equations being graphed at the same time and trying to find the solutions of those. So let's start with that word, solutions. What does solutions mean? This means where the graphs intersect. Okay, so where they meet, that's going to be your solution. Just like if you had linear or direct equations and inverse equations and you were solving those, that's where the graphs intersect. Similarly, here, this is also where the graphs intersect. All right, so let's look at an image of this and see what it actually looks like. So maybe we have a graph, we have a parabola that's opening upwards here, and then we have a linear equation that's kind of cutting through this way. So here we've got 2 points where these graphs intersect. And these two x values are the solutions for these two graphs. So it's where they both meet, so the x values are what we call the solutions for these two graphs. Algebraically, it's going to be a little different. It's actually it's similar, but it's a little different than things that we've done before. So let's say we've got mx plus k equals ax squared plus bx plus c. So first thing we want to do is we want to get everything over to one side. So we'll subtract our mx from both sides, and we get k equals ax squared plus b minus m. So what I'm doing is I'm taking the b and the m and I'm combining them. If they were actual numbers, we would just add or subtract those things together. But since they're variables, we're going to kind of leave it like this. So it's b minus m x plus c. And then we have to subtract k from both sides, and we'll get 0 equals ax squared plus b minus m x plus c minus k. Again, I'm grouping c minus k because if they were both constants, if they were actual numbers, we would combine them together into one. So this is just kind of helping combine it. But one of the key things that we're doing here is we're making this other side of the equation equal to 0. So this always has to be 0. Because what we're about to do now is we're going to factor or use the quadratic formula to find where this thing would cross the x-axis. Okay, so we would get two values for x. Maybe we get one value, maybe we get no values, but we get whatever values we get from our quadratic formula. That, along with the original equations, are the solutions to these equations. So it's the solutions to where these graphs intersect. And I can't stress that enough. It's where these first two equations intersect. That's what we're looking for. That's the solution that we're looking for. A lot of people want to graph this function because this is where these things cross the x-axis. So this quadratic equation are where the values are going to cross the x-axis, the x-intercepts. So that's what this orange one is giving us. It's the x-intercepts. But we have to remember that this is not part of the function or of the graphs. We just use this method to get us to those solutions where the graphs intersect. So don't get confused and graph this middle parabola. The ones that we're focusing on are the original equations, the mx plus k and the ax squared plus bx plus c. Those are the two that we want to really focus on, not the orange one in the middle. Okay, so let's look at some graphs of possible solutions, or the number of possible solutions that you would get with a quadratic equation and a linear equation. So we can start with two solutions. So we'll have maybe a parabola opening upwards and a line cutting across it. Here we've got two solutions where these things cross. Or maybe we have a graph opening downwards and another line cutting across this way. You know, we could come up with lots of different ways, but again, there's just two solutions here. So as long as you're crossing the parabola at two spots, you've got two solutions. What does one solution look like? Well, we could have a quadratic opening upwards, and we could have a line just touching the edge right here. And that would be one solution. Or maybe we have a parabola and we've got a line just touching at the vertex, the minimum or the maximum value. And that's going to be our one solution. And again, we could do horizontal lines. That might give us a one solution as well. So, I'm sorry, vertical lines going straight up and down, and that would give us one solution also. Lastly, we've got zero solutions, and that's going to be where we have our quadratic and a line that's just missing it. So we've got no solutions here. Not going to go into an example with all of these because I think it's very similar to what we've done with our linear and inverse functions. So if you want to kind of see some of the stuff go into action, you can go back to that video. But this is going to work in a very similar manner. Just keep in mind that in the example, or in the blue algebraic explanation above, that quadratic in the middle is not part of the function. Okay, just the top two, the mx plus k and the ax squared plus bx plus c. Can't say that enough. So hope this helps having a toolkit, and we'll talk to you in the next video.